In today's video, here is a nice problem. It's coming from Canary Mathematical Olympiad edition 1999. Here is the following equation involving the floor function. So we have 4x squared minus 4 multiplied by the floor of x plus 51 equals 0 for all x as a real number. Okay. So by the definition, we know the floor of x is an integer. So is the greatest integer is less or equal to x. So as you know, the floor of x is defined as a lower value of x as an integer. Okay, now let's get started. We have this following equation: plus 51 equals 0. Okay, so by the definition of the floor of x, let's set the floor of x equals n. N is an integer. Okay, now by replacing the floor of x by n, so I get here 4x squared minus 40 is multiplied by n plus 51 equals 0. Okay, so I'm going to move over these two terms to the right side of this equation. I get here 4x squared equals 40n minus 51. As we know, if you take a look at the left hand side of this equation, we know this term is positive, so this one is super equal to 0. Okay, so by taking 51 to the right of this inequality, I get 40n super equal to 51. Okay, then dividing both sides by 40, I get here n is super equal to 51 over 40. I get here 1 plus 11 over 40. Okay, so as we know, this term is strictly superior than number 1, since we are dealing with an integer number, which means n must be super equal to 2. So this is the minimum value n can take. So we know which interval we're working on. Now let's go back to the previous equation to discuss what's going on here. Earlier we have defined n as an integer number which is super equal to 2. Now we are going to check what's the status of this equation. Okay, now by the definition of the floor, as we have here, we know x is between two integers, n and n plus number 1. Okay, so by the definition, and also we know n is super equal to 2. Since we have 4x squared, I'm going to transfer this inequality on the form of that equation that I have here. So by squaring both sides of this inequality, I get here, so I'm going to square both sides of this inequality and multiply both sides by number 4. So I get here the following. I get here 16 is inferior equal to 4n squared is inferior to 4x squared is strictly inferior than number 4 is multiplied by n plus number 1 quantity square. Okay, so what I have done here, I just square both sides and multiply all the sides by number 4. I get to this expression. Now we know 4x squared equals 40n minus 51. Okay, so this one, you get 4x squared equals 40n minus 51. Taking this value of 4x squared and replace it into this one to see what this inequality is going to be. Okay, so I will have 16 is inferior equal to 4n squared is inferior equal to 40n minus 51 is strictly inferior than 4 is multiplied by n plus number 1 quantity square. Okay, since I have a long-term inequality here, so I'm going to divide this inequality into two inequalities. Okay, so I'm going to take first inequality, I'm going to take the central inequality which we have here, then taking the other side of this inequality, this one. So I'm going to discuss both inequalities separately, starting with this one, then moving over to the other one. Okay, for this one, for the central inequality, I get 4n squared. By taking these two terms to the left side of this inequality, I get 4n squared minus 40n plus 51 is inferior equal to 0. Okay, let's square this one in blue to make sure we are working on that inequality. Then the second inequality, I'm taking this number minus this number, which is strictly superior than 0. Okay, so I get here also 4n plus number 1 quaternary square is strictly superior than 40n minus 51. Okay, I'm taking these two, I'm going to take these two terms, then move them over to the left. I get strict inequality, which is strictly superior than 0. Okay, this one is giving us, after simplification, I get here 4n squared as a first term. I get 4n squared plus 8n minus this 40n, which is minus 32n. Then number 1 is multiplied by 4, which is 4, plus 51. I get here 55 plus 55, which is strictly superior than 0. Okay, let's square this one in red. So by taking these inequalities and check where we have intersection, so the intersection of this inequality is a solution for this equation. Okay, as defined, f of z equals 4z squared minus 40z plus 51. Okay, g of z equals 4z squared minus 32z plus 55. Okay, so first table, I'm going to solve both equations by calculating delta of these equations, then make the variation table for both functions and transfer this one into the, and then put them in the graph. Okay, if solving this equation, I get f of z equals 0. I get here the following, and also at the same time I'm going to factor out this one on the form of 2z minus 10 quaternary square. As I'm expanding this one, I get 4z squared minus 2 is multiplied by this one, which is minus 40z, plus 100 minus 49. I get 51 minus 49, which is 7 squared. Okay, this one is giving us 2z minus 10 minus this 7. I get minus 17. Factor 2z minus 10 plus 7, which is minus 3, equals 0. Okay, for this one, I get g of z equals 0. I will have the same thing here. I get here 2z minus 8 quaternary square, because if I'm going to distribute this one, I get 4z squared minus 32z plus 64, but I have only 55 here, which I put minus 9. Minus 9 is the same as minus 3 squared, equals 0. Since we have a difference of two squares, I'm going to factor out that. I get here g of z, which equals 2z minus 8 minus 3, which is minus 11, factor 2z minus 8 plus 3, which is minus 5, equals 0. Okay, first root I get here 3 over 2, and second root for this one I get here z2 equals 17 over 2. For the second equation, I get here z3 equals 5 over 2, and z4 equals 11 over 2. Okay, I'm going to take these solutions at the top. Previously we were solving both equations, f of z equals 0, and came up with these two solutions, and we solved the equation g of z equals 0 and found those solutions as well. So the reason why we are solving these equations, to determine the intersection of x-axis and these functions, and we found those intersections as we have here. Calculate the first derivative function of this of f of z. I get here f of z, as I remember, I get here 8z minus 40. If I'm going to solve this equation to determine the critical points of this one, so I get here z equals 40 over 8 which is 5. For the same thing for this one, as I'm calculating the derivative function of this one, I get here hz minus 32 equals 0. So the critical point of this one, let's put it z prime equals 32 over 8, which is 4. So we have the critical point of this function, which is 4. So the critical points of this one, which is 5. Both are the minimum of this function, because since we have this minus sign here and minus sign here, that means we have upper face parabola. So that means the function is accepting number 4 as a minimum, and the other one is accepting number 5 as a minimum for these functions. Okay. Next thing up, I'm going to put this one in the graph and find the solutions for this inequality. Okay. Here is the general picture for this one. By putting this one in coordinate plane, I get here the following. I get here, so for the first function, I get the intersection points 3 over 2, which is 1.5. So the second one for 17 over 2, which is 8.5, will be here. This is z1, this is z2. For the critical points for this function, I get number 5. I get here 5. This is z. This is the solution for this function. So I get here f of 5 is giving us minus 49. Okay, minus 49 will be all the way down around here. For example, I will have upper face parabola. So this is the general picture for this one. So I will have also, for the second function, I get g of z. So I have intersection points z3, which is 5 over 2, which is 2.5. So I will have here another point, 2.5, which is z3. Then z4, 11 over 2, which is 5.5, which is z4. So also I have a critical point at the point 4. Let's calculate f of 4. So here is a critical point z prime at point 4, z at point 5. Okay, is minus 49. For the second function, I get critical point at number 4. So the output of this one is giving us minus 9. If we calculate this one, is giving us minus 9. Minus 9 will be around this area. That's the general picture of this one. I will have this one is going to pass through these points. Okay, so the f of z must be inferior to 0, which is this area below OX, this area, this region. But for g of z must be strictly superior than 0. For the second function, I will have the solution above these points, because we need this function to be strictly superior than 0, which is this area from this one and this one. So where we have intersection between this one and this one, so this region, I'm going to put the intersection. I'm going to put this one perpendicularly. Then this one will be here. So the solution for this equation, it will be this region. So I will have the solution up here, this area, and this area, this region, and this region. Okay, so we are going to pick up only integer numbers, because since we are dealing with the integer names, now our goal, we are going to determine n, okay, as an integer. So we have the floor of x equals n. So we are going to determine the n. We know n is superior to 2. So for this region, we pick up n equals 2 is a solution, because 2 is located between 1.5 and between 1.5, which we have here, and 5 over 2, 2.5, which is this one. So we have only one integer n. We have only one integer n here. So for this region, we get here this point. it was Z4, which is 11 over 2, which is 5.5. For this point, 8.5. So the solution for this area will have 6 and 7 and 8. Okay. So for this region, we found n equals 2 as a solution. In this region, we found 6, 7, and 8 are the solutions. Okay. So the intersection between this one and this one, we found this one. So now we are going to determine the solutions for this equation. So by the definition of the floor, n we have n equals 2 as a solution. So x will be x lives in this interval. We have n, which is 2, and 3. Okay. So because x is strictly inferior than n plus number 1 and bigger than n. Okay. So we are going just replacing n with these values. N equals 2, 6, 7, and 8. For the second value, I get n equals 6. I will have another solution, which is 6 is inferior to x strictly inferior than 7. Okay. For the other value, I get n equals 7, implies, so x, it will be between 7 and 8. Lastly, I get n equals 8, which is x, it will be between 8 and 9. Okay. So this is 4 solution for x that we have. Okay. So I have ended this video. If you have any question regarding this problem, just put it in the comment section below. But also, if you have any question or suggestion, just put it in the comment section below as well. By the way, don't forget to support us with a like and subscribe. Thank you for watching. I will see you next video. Bye.